Good morning, students. Good morning to all. Yesterday, we discussed about the basic introduction of aldehydes, ketones, and carboxylic acid. Today, we shall continue our discussion. See, aldehydes, their common name, and ketones, their common name, and Iupac name, just we glanced. So in writing Iupac name of aldehydes and ketones, we shall have some examples. Say it's a benzene ring which contains an aldehyde group CHO. The base compound is benzaldehyde. Another substituent we have. Now its Iupac name is, say, 1, 2, 3. It is a ring compound. If in a ring compounds aldehyde group is there, its Iupac name is written as carbaldehyde. We discussed yesterday. So its Iupac name is see 4-bromo benzaldehyde. See 4-bromo, and if it is a ring, benzene carbaldehyde is also written. Benzene carbaldehyde. See again, if it is a cyclohexane, again on the aldehyde group we have. So base compound is a cyclohexane. It is a ring compound. Therefore, its Iupac name is cyclohexane carbaldehyde. Cyclohexane carbaldehyde. Are you clear? See, if again 2 or more aldehyde groups are there, then also it is named as, say, CHO, an aldehyde group, along with a hydrocarbon chain, CH2, CH, again CHO, CH2, and again CH2. See, in this example, particularly, we can see 3 aldehyde group, 1, 2, 3. And parent hydrocarbon we can find, it is 1, 2, 3, which is nothing but propane. It is named as propane 1, 2, 3 tricarbaldehyde. The aldehyde group is named as carbaldehyde. Therefore, its Iupac name is, see, propane 1, 2, 3, then tricarbaldehyde. Are you clear? This is how we can easily write the Iupac nomenclature of aldehydes. If you go for ketone, we shall go for ketone. See, in ketones, one of the hydrocarbon which contains an aldehyde group as well as CH3, CH2, C double bond O, CH2, CH2, again CHO. See, this hydrocarbon contains 2 functional groups. One is aldehyde functional group, another one is ketone functional group. So you have to nomenclature. What is its Iupac name? So you have to, when 2 functional groups are there on a carbon chain, so preference will be given to one of the functional group, which is called principal functional group. See, in the arrangement of the functional group series, aldehyde group lies above ketone. So therefore, one functional group will become a prefix and another will become the suffix. That you studied in first year. In a hydrocarbon chain, two functional groups are there. So you have to give priority. In priority between aldehyde and ketone, priority is given to aldehyde. Therefore, aldehyde functional group is a suffix and ketone functional group is a prefix. If it is a carbonyl C double bond O, in prefix it is termed as oxo. It is termed as oxo. So therefore, its IUPAC name is first number the carbon atom 1, 2, 3, 4, 5, 6. So therefore, it is nothing but hexanol. So we can find in fourth carbon atom an oxo group. Therefore, 4 oxo hexanol. Are you clear? So it is an hexane and the suffix name is here aldehyde, which is termed as Al. Are you clear? So this is how we can write the IUPAC name when an hydrocarbon contains an aldehyde as well as a ketonic group. Are you clear? Understood? Yes. See, again, if suppose two functional groups are there, see it is nothing but a ketone and again one CH3 group is there. So it is nothing but a benzene ring. So you can find here 1 to 2 methyl phenol. Are you clear? Okay, like that we can easily write in any substitution. Say CH3, C double bond O, CH2, CH2, C double bond O, CH3. A simple hydrocarbon which contains two ketone group. So therefore, the suffix name is nothing but ONE. It is a ketone. Say 1, 2, 3, 4, 5, 6. So therefore, 6 means hexane. Hex, say it is hex 2, 4, 2, 4, 4, dione. Are you clear? See, two ketonic groups are there, therefore it is termed as a di. If it is a ketone, its suffix name is ONE. Are you clear? It is a ketone, therefore its suffix name is ONE. It is nothing but a hexanone. In hexanone, you see the carbon chain, we can find two ketonic groups at second carbon atom and as well as at the fifth carbon atom, not fourth, fifth carbon atom. So therefore it is hex 2, 5 dione. It is nothing but hexanone. So this is how there are many examples in your textbook. Go through it, write the IUPAC name, and one question can be appear for your annual examination. Okay, we shall continue our study for the preparation of aldehydes. So dear students, we completed the IUPAC name of aldehydes and ketones. Now we shall discuss about preparation of aldehydes. See, in completion of the alcohol, phenol and ethers, we have already completed the topic and we studied the oxidation reaction of alcohol. When an alcohol is oxidized in presence of a mild oxidizing agent like chromic oxide, an alcohol can be converted into an aldehyde. See, in last class we studied that. And we have to study more examples. Say alcohol RCH2OH. See, when it is oxidized in presence of a mild oxidizing agent, like CrO3, then we will get RCHO. So, which is nothing but an aldehyde. We studied this. Okay, and we have to study the preparation of aldehydes in terms of named reactions. There are 3 to 4 named reactions are there, very, very important for your examination point. Here, alcohols on oxidation with mild oxidizing agent will get aldehyde. If you use a strong oxidizing agent like acidified potassium permanganate or potassium dichromate, an alcohol can be oxidized to carboxylic acid. So that is the basic which you already know. Now we shall study preparation of benzaldehyde. So benzaldehyde can be prepared by preparation of benzaldehyde. Preparation of benzaldehyde first. A. So this is a benzene ring, and again we have C double bond O Cl, which is called benzoyl chloride. See, benzoyl chloride. So it is nothing but an acid chloride. See, when acid chloride is reduced, See, in the presence of palladium as a catalyst with barium sulfate. So it is nothing but an hydrogenated, where it is plus H2. So we will get benzaldehyde. See, this is nothing but benzaldehyde. Are you clear? It is nothing but a reduction. You are added hydrogen. So, and particularly this named reaction is called Rosen Mud Reduction. It is called Rosen Mud Reduction. When an acyl chloride is reduced, it is a reduction in presence of catalyst palladium by using barium sulfate. Reduction takes place and it forms benzaldehyde. And this particular reaction is called Rosen Mud Reduction. What is the reagent used in Rosen Mud Reduction? So that is palladium in barium sulfate, and it is called Rosen Mud Reduction. A well-known reaction. See, benzoyl chloride C6H5COCl, when it is reduced hydrogen in presence of palladium and barium sulfate, benzaldehyde is obtained. This reaction is called Rosen Mud Reduction. Are you clear? A named reaction. See, every time we will ask for 1 mark. Name the reagent used in Rosen Mud Reduction. So that is nothing but palladium in barium sulfate. So it is a reduction reaction. Therefore, it is called Rosen Mud Reduction. Particularly, it is called Rosen Mud Reduction. Are you clear? Understood? See, when acyl chloride, particularly you have to take benzoyl chloride. See, if CH is there, it is called, and CO, therefore it is called benzol. It is an acid chloride. It is an aromatic derivative. See, we will write like CH3COCl, acetyl chloride. So like that it is benzoyl chloride. So explain Rosenwood reduction. When benzyl chloride is benzol chloride is treated with catalyst palladium in the presence of barium sulfate, on reduction benzaldehyde is formed. This reaction is called Rosenwood reduction. The reagent used for the Rosenwood reduction is catalyst palladium in the presence of barium sulfate. So, name the product formed in Rosenwood reduction. Benzaldehyde. What is the initial reactant? An acid chloride, which is called benzol chloride. Are you clear? I think you are very clear, and every time we will ask this one. And before last year, for your annual examination, one more question is appear on this. So you complete the reaction. So you have to write the product, that's all. Sometimes you have to write the Rosenwood reduction reagent. So the reagent is palladium in barium sulfate. So what is the process here? It is nothing but a reduction. See, oxygen is and hydrogen is added there. So therefore it is a reduction. Are you clear? Okay. So this is called Rosenwood reduction. So a well-known reaction, very slowly, repeatedly, I am going to tell you. So this is always one of the question for your annual examination. Okay, we shall study other preparation, that is preparation of benzaldehyde by nitrites. See, preparation of benzaldehyde from nitrites, from nitrites. See, nitrites are CN. So when it is treated with see, stannous chloride SnCl2 in the presence of hydrochloric acid, and imine is formed. See, RCH double bond and H, so which is called imine, and imine is formed. On hydrolysis, we will get aldehyde RCHO, a well-known reaction. So which is called Stiffener's reduction, and Stiffen reduction. Are you clear? Nitrites can be converted into an aldehyde. An intermediate is formed. That intermediate is called imine. So what is the reaction? When the nitriles RCN, see, when it is treated with stannous chloride in the presence of hydrochloric acid, on reduction, see, SnCl2, 2HCl will get SnCl4 and 2H. See, particularly RCN plus 2H. So what is the, see, SnCl2 plus 2HCl, and we will get SnCl4 plus 2 hydrogen. And this hydrogen reacts, and we will get what? Imine, an intermediate product. And finally, on hydrolysis, we will get what? RCHO. Are you clear? See, final step is on hydrolysis. We will get an aldehyde, and this particular reaction is called Stiffener's reduction. So, in a Stiffener reduction, what is the Stiffener reduction reagent? What is the initial reactant? and what is the product that you have to convert. See, in Stiffener's reduction, the initial reactant we are going to select is nitriles. Understood, dear students? Nitriles. Nitriles on reduction with, what is the reduction? Reagent stannous chloride with hydrochloric acid. Stannous chloride with hydrochloric acid on reduction gives imine, where CH double bond NH, that particular an intermediate is called imine. That imine on acid hydrolysis we will get an aldehyde. Are you clear? Very simple, very simple. Understood? And this particular named reaction is called Stiffener's reduction. See, dear students, you completed two important reduction. One is Rosen Mud Reduction, another one is Stiffener's reduction. In Stiffener's reduction, the reagent used is nitrile, and reduction reagent is stannous chloride and hydrochloric acid, and product obtained is aldehyde. Are you clear? Okay. We shall continue. Say, in your textbook, particular reaction is given, and that one you have to write that down. And this particular reduction is called Stiffener's reduction. Stiffener's reduction. STEPHNS, Stiffener's reduction. In Stiffener's reduction, the reactant used is nitrile. Intermediate product is imine. And final product on acid hydrolysis is aldehyde. That's all. So our aim is to prepare an aldehyde. See, in Stiffener's reductions, the reduction reagent is stannous chloride and hydrochloric acid. And alternatively, we can also prepare aldehyde by using other catalyst, and that is diisobutyl aluminum hydride, C, or Cl. And we can use diisobutyl aluminum hydride. If this is an reagent, again on reduction, we will get C minus or CH NH. Again on hydrolysis, and we will get RCHO. Understood? So what is diisobutyl aluminum hydride? See, diisobutyl aluminum hydride. So here also same thing. An imine is formed. So it is nothing but a reduction. And again we are going to use nitrile. See, nitrile is reduced to aldehyde by using an catalyst diisobutyl aluminum hydride, as Stiffener's reduction. An alternative method we can apply to prepare an aldehyde. Are you clear? So nitrile. See, it is nothing but 2H, and again particularly we have one example. See, CH3, CH2, 9 times, then again Cl, which is nothing but a nitrile. See, on reduction. Say it diisobutyl aluminum hydride. So we will get see CH3, again CH2, 9 times, then again CHO. Are you clear? So this is nothing but and finally on acid hydrolysis, and we will get a decanol. Are you clear? So this is how we can easily prepare. And even ester can also be converted into an aldehyde. Ester, see, CH3, again CH2, say 5 times, again O, C2H5, C2H5. So an ester, see, any ester can also be changed into, again, diisobutyl aluminium hydride. See, again final on hydrolysis, and we will get aldehyde. Are you clear? A very simple reaction. Even ester can also convert it into an aldehyde. Are you clear? Okay. So these are important reactions which you have to remember. See, alternatively, we can prepare aldehyde by using diisobutyl aluminium hydride. Okay, we should study next part, that is second, from hydrocarbons. Particularly by toluene. See, it is nothing but an oxidation. See, toluene. See, formula for the toluene is benzene ring and CH3, which is toluene. See, when the toluene is oxidized, by using an oxidizing agent, chromyl chloride. See, CrO2, Cl2 from chromyl chloride. CrO2, Cl2, chromyl chloride. What is the formula for chromyl chloride? CrO2, Cl2. Chromyl chloride we studied in the P block elements. See, in the reaction of chlorine with calcium hydroxide, a chromyl chloride bleaching powder which can be prepared. Okay, so which is toluene. If it is oxidized, in the presence of chromyl chloride, see, CrO2, Cl2, chromyl chloride. So in the presence of carbon disulfide, CS2. So we will get an intermediate complex. An intermediate compound is obtained. See, an intermediate compound OCrOH Cl2 twice. So intermediate compound is formed. Say this on again hydrolysis. This on acid hydrolysis, and we will get benzaldehyde. Say benzaldehyde. See, from toluene, benzaldehyde can be prepared, which is an oxidation reaction, and oxidizing agent is chromyl chloride. Intermediate compound formed is the derivative of chromyl chloride. That's all. And this particular reaction is called Iupac reaction, and it is Iupac reaction. Are you clear? Dear students, in Iupac reaction, the base compound is toluene, final product is benzaldehyde. Toluene is oxidized in the presence of chromyl chloride, and we will get finally on acid hydrolysis benzaldehyde. That's all. See, don't by heart the name reaction. Just watch what is initial reaction, what are the reagent used, and what are the final product. That's all. See, in Iupac reaction, chromyl chloride is a reagent used. The initial reactant, which is an aromatic hydrocarbon toluene on oxidation. What is the chemical reaction takes place? It is oxidation. Who favors oxidation? Chromyl chloride favors oxidation, and it forms an intermediate compound. So that intermediate compound on acid hydrolysis gives benzaldehyde. That's all. Are you clear? And particularly it's an oxidation of toluene by using chromyl chloride. And it is studied, and that particular name of that reaction is Iupac reaction. Iupac reaction. Explain Iupac reaction. When toluene is oxidized in presence of chromyl chloride on acid hydrolysis, benzaldehyde is obtained. This reaction is called Iupac reaction. Are you clear? Very, very simple reaction. Say, dear students, in this aldehydes, ketones and carboxylic acid, many named reactions are there. And at least 4 to 5 named reactions can be asked for your annual examination. You have to practice, repeatedly you have to practice. Students are answering in annual examination, but somewhere partly they are going to wrong. They are written wrong. They are writing wrong. And you will get less marks. Are you clear? Be aware, be concentrate, study, write again and again. Easily you can remember. Okay? So just understand, when an hydrocarbon, aromatic hydrocarbon, particularly toluene, is oxidized in presence of chromyl chloride, and finally on acid hydrolysis, benzaldehyde is obtained. An intermediate compound is formed, which is OCrOH Cl2 which is called an intermediate compound, a chromyl chloride intermediate compound. Okay, so instead of chromyl chloride, that chromic oxide, see, Cr2O3, and as well as acetic anhydride, CH3CO twice. Acetic anhydride can also be used. Same reaction, same type of reaction. Again, you will get an intermediate. See, COCH3, which is an intermediate, and which is on acid hydrolysis. Again, we will get benzaldehyde. Benzaldehyde. Are you clear? And this particular reaction is also a part of it. We are going to use acetic anhydride in place of chromyl chloride. Again, oxidation reaction. Everything is same. And in final step, we will get an benzaldehyde. So therefore, this is nothing but the named reaction we studied. Dear students, I am little bit late to start the class due to some network problem. Only half an hour class. I will stop here and I will continue tomorrow. So we completed 3 important reactions: Rosen Mud Reduction, Stiffener Reduction, and Iupac reaction. Okay, thank you. ನೋಡಿ, ನಾನು ಕರೆಕ್ಟ್ 10 ಗಂಟೆಗೆ ಬಂದ್ ಮಾಡಿದೆ. ಈಗ ಎಷ್ಟು 10:05 ಆಯ್ತಾ? ಇಲ್ರಿ.